AWS User Group 3City. I hope today we will have a very nice topic, very great speakers, and you will enjoy this kind of the event. Today we are hosting this event together with Amazon Development Center Poland in their office. So sorry for this delay. It was, as usual, the security check is a security check. It's sometimes happened. As probably most of you know, tomorrow in Gdańsk we will have the InfoShare conference, one of the biggest conferences in Central Europe region. And I hope tomorrow, actually, could you please raise your hand who tomorrow will join the InfoShare conference or who at least know about that? Wow, great. Some people already know. If you don't know, I will share with you later the details. Why I mentioned this? Because we are the InfoShare partner as a community, and we have the 10% discount for any kind of the tickets if you would like to buy. And also, I have one more ticket, and we will draw it later today for the most active, let's say, people who asking the question. Also, at the same time, with the AWS support, we have the AWS credits and the community group meetups. It's one of the great places when you can receive the AWS credit and use it for the learning purposes, for your pet project. So be active, ask the question, and we will reward you back. Also, some kind of the agenda. Today we'll have two topics and short break between them. And after that, we will have pizza and networking. Also, feel free to grab the stickers on this desk. If you need the Wi-Fi access, you also can find the password here. And what else? Let's use the time wisely. I would like just to say one more time, thanks to our partners, our sponsors. It is EPAM Systems, it is the InfoShare, JetBrains, and AWS and Amazon Development Center Poland as well. Last but not least, today I would like also to introduce the Grzegorz Kalwig, which will be the first speaker as a new co-leader of AWS User Group 3City. So greetings to Grzegorz.
Thank you.
And I hope with the new energy, we will conduct more great events, more great speakers. So all for you guys, thanks for coming and stay tuned. And let me pass the floor for the Grzegorz and his presentation. So I hope you will enjoy it. Grzegorz, the floor is yours.
Thank you very much. So I will present today a topic about DNS. I have hope everyone heard about DNS problems in project. I like to look out for this and deep dive to the DNS problem in production system of e-commerce. And we look what we can find in this case. My name is Grzegorz, like Anton said. I am new leader of this AWS user group. Also, I am the DevOps engineer professional and security specialty certification. And what's more, I work with AWS and Kubernetes to create e-commerce platforms. Okay, for the start, we find the source of the incident on the production system. Then we think about available solutions. During that, I will present you a demo about how to implement these solutions in real environment. And at the end, I present you the other issues we can found on our systems based on the EKS on Amazon Web Service. So let's start to define the problem. The main problem is our clients get the page, it's not working error. The IT guys don't look on the icon, don't look on this pop-up, they look on the HTTP error 500. We know something wrong is with application, with system. It's not problem. It's not client problem. But how we can find the right cause of the incident? I like to present you the, in my opinion, the easiest way and the most some easiest way. So this is the 5 whys rule. We need to start from the define the problem. We have the problem about the error for our clients, and we need to start for asking ourselves why. Why is it happening? Why is that? Why, and why? How long? This rule told us about 5 iteration of whys is enough to find the cause rule, root cause. And let the non-technical example. I am fatigued. Why? Because I sleep briefly. Why? Because the child woke me up. Why? Because it doesn't sleep through the night. Why? Because it wants a nighttime portion of milk. And again, why? Because the time between evening and morning is too long. So, go to the first why. Why do we receive information that website isn't working? It's log from our monitoring system, and we have information about high HTTP 500 error rates. Our error rate is about 2.3%. So from my perspective, it's high because 2 persons, more than 2 persons for 100 clients have HTTP error. How it looks on the graph? We have issue from the half hour, no, 15 minutes, so around 15 minutes, when the error rate goes up, and after that the error rates go down and again go up, and this iteration go during this time. So let's go forward to the second why. Why are we receiving these 500 errors? And in the logs of our application, we can find the PHP network get address info failed. Could not resolve host example.com. Java net unknown host exception example.com temporary failure in name resolution. Java unknown host exception, unknown error, and so on and so on. So some .NET application we have services right in Java and services right in the PHP. So we know we have errors with applications, and we need to jump to the third why. Why aren't DNS name being resolved? And these errors with the diagram of how much errors we have, we can say something like CoreDNS don't receive results from AWS VPC resolver when system is under heavy load, because this time where the issue occurred, we have promo campaign, so a lot of people like to buy something on our e-commerce platform. why we are hitting the VPC resolver limits. Let's deep dive to the application and look how it's constructed. This application received a HTTP request from the client. Then for each external service this main service use, it creates a new thread for asynchronous task. Example, I don't know, database, Redis, external API, and so on and so on. And then it's query that service and wait for the every task complete. Then collect all the responses and based on them create a response, final response for the client. So one request to our service creates multiple DNS queries to resolve. And now we can ask the 5 why. Why is the VPC resolver rejecting our queries? In the AWS documentation, we can find that each AC2 instance can send 1024 packets per second per network interface to Route 53 resolver. Route 53 resolver is a default resolver for our VPC. Each service in the VPC asks this resolver to resolve DNS domains. And network interface, we can say it's something like IP address of this service. We know we can have network interfaces with multiple address, but every network interface can ask 1024 packets per second. And the most important thing is this quota cannot be increased. So we cannot increase this limit. We need to accept it and we need to adapt our solutions or system for it. So what we can do? First of all, we can increase the number of CoreDNS replicas, because in the EKS cluster, the Kubernetes cluster, CoreDNS is the resolver of names for this cluster. And the default configuration till the last week, EKS came to us with 2 instances of CoreDNS replicas, but from the last week, AWS changed this, and when you use the standard default add-on for EKS, they have default compatibility with the autoscale, the CoreDNS replicas. So we will see how it can change when we increase the number of CoreDNS replicas, like this autoscaler will increase the number of it. Okay, the second solution, we can changing the CoreDNS configuration. Example, we can increase the cache time, so our CoreDNS can cache the resolves more till the more time, so it don't need to ask the VPC resolver too many times for specific DNS name. The third solution, we can apply node-local-DNS. It's special I can say, the implementation of CoreDNS, where we put the CoreDNS as a daemon set on each node. So the services on the specific node don't create a request to another node, but ask the node-local-DNS, the DNS resolver locally on the same node. And the last one, we can use application level caching. It's something like PHP. Don't have at the default the cache, and each query needs to create a new request to the database, new request to the external services, and we can make some application level caching to decrease the number of queries for the external DNS resolver. And at this point, I will change the view to our system. Okay. It's my IDE. So I like to show you what we have in the cluster. As you can see, we have the Prometheus to get metrics from the kube state metrics and from the CoreDNS. And also we have a Grafana to visualization, for the visualization of these metrics. And the last component I add to this cluster is DNSPerf. DNSPerf creates a lot of DNS queries for our CoreDNS and for our VPC resolver. Okay, so fast look to the kube system namespace. On the kube system namespace, we have 2 instances of CoreDNS. This is the most important thing on this cluster. And no node-local-DNS deployed at this time. So let's look to the metrics. As you can see, our cluster generates around what? 2,200 requests per second, and we have some around 1,000 misses and up to 1,600 hits to the cache of the CoreDNS, and the time of response is 0.2 millisecond from CoreDNS. And this is the beginning of our demo. Okay, so what I need for now? First of all, we have the 2 CoreDNS pods. I do it more clear and just CoreDNS print. Okay, we have 2 CoreDNS pods, and I like to have top on these pods. Okay, as we can see, This is our 2 pods or 2 instances of our CoreDNS, and each of them use up to 30 megabytes of RAM, and one instance use 78 milli CPU, and the second one used 400 milli CPU. And if we change the configuration, I don't will add the auto-scaling of CoreDNS. I just added the deployment of CoreDNS in namespace kube system. As I said, it's live demo, so I will change the editor for kube configuration because we have the colors in the nano. The previous one is Vim, so I am the team nano, not team Vim. Okay, as we can see in this deployment configuration, I will just scroll down a little bit. We have 2 replicas. I will change that for the 4 replicas. And now we need to wait a moment to our new replicas of CoreDNS starts and take a traffic. Okay, as you can see, the another 2 replicas started. We need to wait some about 1 minute because the kubectl top pods need 1 minute to have a scrape the metrics. Okay, and we can see the another replicas starts handle traffic, and for now we have the 4 instances of CoreDNS, so the CoreDNS can be put across our cluster, and we have the 4 nodes in this cluster. This is our nodes 1, 2, 3, and 4. So each of these nodes have another network interface. So each of these nodes can ask VPC resolver 1024 times. Okay, it's our first modification of our cluster configuration. Let's deep dive to some magic with node-local-dns. I have a prepared configuration to the node-local-dns in my file, so I will put kubectl apply -f node-local-dns. Yeah, this file, this configuration creates 5 things. First of all, we have service account for node-local-dns. The second, we have the service for kubeDNS upstream. It's a specific service to forward requests to the CoreDNS. Then we have config map for the node-local-dns to have ability to change their configuration. Then, as I said at the beginning, we have daemon set to put that node-local-dns pod on each node. And the last thing is service node-local-dns And this service was the standard DNS from now to our application. Okay, we can look at the cluster to find our node local. And as you can see, we have 4 node local DNS pods already running. I give them around 5 minutes to make some noise to our metrics, and I will come back to the presentation. What other issues we can see in our EKS clusters? First of all, we need to speak about quota and limits, because this 1024 request to the VPC resolver is one of the quota limits we had. First of all, we need to think about bandwidth capacity. So instances, EC2s, have a maximum bandwidth for traffic. So when we put the node-local-DNS, we decrease the traffic, the DNS traffic in our system. We have a lot of DNS queries in the standard implementation, because the CoreDNS can be only in 2 instances, and all requests will be transferred to this EC2 instance, and maybe this instance can hit the bandwidth capacity limit. And the second thing, when we talk about the networking, is packet per second limit. Instances as well have a maximum packet per second performance and have the limits how much packets you can send to and from this instance. Also, we have some maximum number of connection can be tracked by instance, but this is the thing at the system layer. So you can change this in Linux and increase the number of connection you can monitor in contract, but it's also limit. And the last one, link local service access, it's a maximum packet per second network interface for traffic to services such as DNS. This is what we talked before, but this limit, it's not only for the DNS, it can be also for other services like the DNS. And the last example of issues we can have during the resolve names and no service appear in the cluster, it's sudden disappearance of resources from the clusters. I like to present you how Kubernetes and EKS cluster delete your resources from the cluster. At the beginning, we have example delete pod command. When you put delete pod command on your kubectl interface, you send a command to the API server. The API server sends this command to the kubelet where this pod exists, and kubelet send this to the container, and the pod is deleted because the hypervisor of the container, I don't know, containerd or Docker daemon, delete this container. But it's not all, because we delete the container. We don't stop send the traffic to this container. This is other path for Kubernetes, because when you put the delete pod command, you start the two flows. The first flow at the bottom ends at the pod deleted, but the second flow starts again from the API server. Then API server sends that information to the endpoint controller. Endpoint controller accept that and send information through the API server to reach the kube proxy, and kube proxy need to change rows in the API tables to stop send traffic, to stop accept traffic for the specific container. And when this first flow is shorter than the second flow, we have new connection failed. When we have a connection before pod delete and pod suddenly was deleted, we have interrupt communication. So what we can do with this? We can put some wait for this flow at the bottom to give container time to give time for the cluster. So not kill that container ASAP. Wait, I don't know, 90 seconds and delete this container after the 90 seconds. And during this 90 seconds, we give a Kubernetes time to delete rows in the IP tables and close all connections for this container. And how often you can find this? From my perspective, the medium size of e-commerce system, we have several requests per week which have this issue, and we changed in every service. We added this grateful shutdown time for containers to the 60 seconds to give Kubernetes some more time to close IP tables for this container. Okay, I think we can come back to our metrics. As you can see, from the 2000s of requests to the CoreDNS, we already be at the 0, I don't know, it's 1. So we have 1 request per second to the CoreDNS because we have cache on our node local DNS. And also the cache hits misses, it's linear also, because what have been transferred to the CoreDNS, it need to be cache miss, because the node-local-DNS put the cache job for its own. And the time for the response from the CoreDNS, it's around the 0, because all the pods of the CoreDNS do nothing. Yeah? Yeah. As you can see, we have 2 milli-CPUs usage for each instance. So we can change this for CoreDNS, come back to the 2 CoreDNS instances, because also the VPC resolver don't have a lot of requests from our EKS cluster. And from my perspective, it's all. And I think it wasn't DNS, because DNS is very old protocol and very old services. It's just proper configuration for our needs. And we need to sometimes focus how we use our cluster, how our services use the core components of our cluster. Thank you very much. And if you like, you can follow me on the LinkedIn, and of course follow our Meetup and our user group for the interesting events, and I think the fresh view from my side to this community. Thank you very much.
Yes. Guys, now we will have 5-7 minutes break, so feel free to grab free water on the kitchen or far the toilet near the elevators. For our global audience, we will back in 7, let's say 10 minutes. Take rest. And hey everyone, welcome back. And let me pass the floor to our second speaker is Wojtek Gawronski, Senior Developer Advocate for AWS, and his great topic about generative AI. I hope you will enjoy. Grzegorz? Oh, sorry. Wojtek, the floor is yours.
Thank you so much. Yeah, Anton already spoiled a little bit about the topic. It will be about generative AI, but I promise it will be around certain context in terms of security. This strange title may look unfamiliar for many of you. It's not a made-up role, I can guarantee. The role of the developer advocate is to actually meet the customers at such meetups like this. Listen to builders, listen to people that use on a daily basis AWS. So if you have any feedback towards us, you would like to provide some information, you would like to give us an honest feedback about certain stuff, I'm all ears for you. Let's do a show of hands, because I think we will have an interesting response here. How many of you heard about threat modeling? Raise your hand, please. Okay, 3, 4 people. How many of you are having currently generative AI workloads at your companies? Raise your hand. A little bit more. So yeah, if I will ask how many of you are applying threat modeling to generative AI applications, I would expect to see nobody. Okay, good. So definitely you are in the right place. I hope you will learn something new today as well. As I promised, this will be generative AI in the context, because we all operate in that context, and we should have this context in mind. If you are building a new stuff, and in our jobs we have this great opportunity to actually deliver stuff and being innovators, explorers, someone who is actually dealing with the new technology on a daily basis. We feel excitement, we experiment, we do the prototyping. But then we would like to deliver those prototypes to a customer to give them a new experience, an innovative one. And generative AI workloads and similar stuff is exactly like this story. So you are creating something that should improve your customer experience. For example, we are creating a chatbot. What a surprise, especially with generative AI. So you can actually create this chatbot that will be powered by large language model, which will improve the whole e-commerce experience. For example, customer would like to buy those shoes and upload the picture of those shoes and ask, can you provide me similar shoes to those? And then our friendly chatbot, with the power of semantic search, analyzing the context, then rephrasing it, and all the power that is behind LLMs and vector databases, throws out the response and says, in our inventory, we have those shoes that looks as the ones that you uploaded. And that's great. Everybody are satisfied, maybe surprised with the outcome. But in the end, we are starting to think that even that we are dealing with the new tech and innovate around us, we need to apply all of those good practices that we applied in the past for regular systems, for those which are less innovative, and I use air quotes because they are as important as the most innovative ones, but at the same time, we should think and remember to apply those best practices. And security is one of those topics. Like, I strongly believe as a programmer, architect, and someone who delivers those systems, that security is everyone's job. Like, there is no person that is responsible for security by job title. In terms of software development, everybody should think at least about security. And if we are dealing with those prototypes, this new tech, it means that we need to think also in the context of the security as well for those new stuff. For example, what new security risks are we introducing by adding this particular technology to the picture? Is there anything specific to generative AI in that sense? Maybe we are opening new surface attacks. Also, what kind of risks should we mitigate? What can be avoided? And maybe what stuff needs to be accepted as is? And last but not least, how to get started, because this is always a struggle with the new tech. So we can answer all of those questions with one process. And it sounds like snake oil and someone who is actually selling you something new. But actually, this topic and the process is well known and well documented. It's called threat modeling. So those of you who participated in the threat modeling exercise. This may be a very familiar view. For those of you who haven't participated, this may look overwhelming already. We do have a table with a lot of information that contains a lot of very, very nitty-gritty details. And also we have LLM and generative AI specific vocabulary here as well. So let's dissect this and let's focus just on the first row at the moment, and let's try to go through the whole threat modeling exercise together. In general, threat modeling is a team activity that we involve multiple views and multiple personas to give us information about possible threats. What can go wrong and what can happen with our application to actually identify, communicate, and understand all of those bad stuff that can happen, and how to mitigate those stuff to actually protect something that has value inside our applications. So essentially, this is a brainstorming session with all the stakeholders, that includes technical and business stakeholders, that will explore the potential bad stuff that can happen with the apps. And you do this exercise together. So that's why we are involving so many perspectives, to actually make sure that we are involving, we are actually having all the views and necessary points on that. And it requires practice. It may sound a little bit more than like art than a science, but there are other tools, checklists, and frameworks that may help you to go throughout the process. And the whole exercise is actually framed in something that we call a 4-question frame that is created by Adam Shostak. Have you heard about those 4 questions? Raise your hand. If not, we will go them one by one. So what are we working on? That's the first question. Obvious one. It may sound silly if we are trying to ask that question when we're developing such a new system. But at the same time, the whole purpose of that question is to make sure that we are on the same page with all stakeholders. Because uniformly, we may not understand the same functional and non-functional requirements in the same way. Second question is, what can go wrong? That's the essence of the whole threat modeling. We are trying to brainstorm what may happen in a bad way with our systems. Then the third question, what we are going about it. Are we mitigating those things? Are we accepting the risk? Would we like to avoid this completely? We need to answer those questions and think about the possible mitigations to actually make sure that they are aligned with the business risk and they are aligned with the risk analysis that we are doing. And the last question in that 4-question frame that we are actually doing is did we do enough job in terms of the whole process? And this is not a situation when we are self-patting ourselves in the back that we did a great job with security. This is a situation that we are actually trying to reflect on the whole exercise. So this is like retrospective or anything that allows you to improve for the next iterations. So as you can imagine, if we have 4-question frame, we will obviously start with the first question. So what are we working on? And this step is actually a discussion. Obviously, if we are asking a team of people, when we have business stakeholders, technical stakeholders like developers, architects, and the security personas, and to those security personas we will later return. But if we will ask all of those personas, what are we working on? Obviously, developers will raise their hands and they will race to the whiteboard with their diagrams, all the colorful ones. They will bring the mock-ups. They will have everything prepared and ready, and they will start to explain everybody that we are using this service to do that and to this and so on. And by the half of the explanation, business people are either falling asleep or they are leaving the room. Because at this point, we are overwhelming everybody with very important but unnecessary details. First, we need to agree on certain business capabilities and flows, how data is flowing throughout our application. So in order to start the discussion about what are we working on, we are starting from something that is called a data flow diagram. Much simpler, right? Like sticky man, cylinders, a few boxes, whatnot, and obviously arrows. But at the same time, this could be very well explained from the perspective of business processes and how data are flowing through our apps. So we can imagine a situation that our user navigates to a website, then it fills out certain stuff in the component that is on the website that we saw as a chatbot widget. It sends the prompts on the client side. It provides that to the API. API sends that to the business logic, transverses to directly there. Then the business logic is querying the LLM, and as a result, returns everything that our fabulous model returned. Then we, again, try to go to the database with those embeddings, probably with those responses for LLMs. We are getting all the inventory back, and we are returning this to the business logic, and that returns to the customer with the final response, again, wrapped by the business logic. So much simpler flow, maybe in some cases for people and technical people oversimplified, but at the same time, it allows you to drive the discussion around important stuff, important business capabilities. For example, if I will show a previous colorful diagram to people that are non-technical, they don't know where to look for a database in the diagram, because they don't know that OpenSearch Serverless, for example, is a database that stores all the details. On the contrary, right now, the database is there. It's a cylinder. And it actually gives us a little bit better approach to ask valuable questions. For example, you can imagine a situation that after explaining the whole flow, security persona may ask, okay, so a user is providing a prompt to the chat widget, and then we are filtering based on the content of that prompt, the content of the whole database, right? And developer says, yes, we do. And the security persona says, huh. And that's already a bad sign, because those people, when they are saying, huh, they're already making up scenarios in their minds. And that's good for the threat modeling process if they are on our side, obviously. So recap what was the purpose of the first question. We evaluated products and features and use cases that we had in our app. We briefly looked on the high-level architecture, and also we explored the data flows. But again, this was a starting point. Now it's time to ask developers about more detailed implementation side. Because all of those questions that will appear throughout this first exercise, they will be asking about deeper dives. They will ask, okay, so what is the querying language for our database? What API calls are we exposing? And so on and so on. So we need to design documentation, but maybe not from the start. This should be an artifact that we are using anyway, but not at the first thing. Second thing, throughout the exploration, all of those data flows and use cases, we are investigating and writing down all the assumptions that we made. For example, are we assuming that all the training data provided to our model are correct? They are not having any malicious stuff already. If that was our assumption, we need to write down that assumption, because that will be important later. And those assumptions are not covering just the generative AI space. They are covering everything. So we need to make sure that the assumptions are written down for the next phase. And then we have a plethora of more opportunities that should actually define very well how the application is built. We need to document all of that. And as a result of this first step, we will use it as an input for a second question. What can go wrong with what we are trying to build? And this is a pretty interesting experience already, because we have answer from the first step. We know what we are building, but that's not enough to do the brainstorming, right? We need to ask business, okay, so what are our risks? What is acceptable risk for us? What is the most dangerous situation that may happen? And those people will answer, okay, so if we will have an information disclosure, this will be a disaster for us, because our business cannot function if we will have this information disclosure because we are a highly trusted website. We need to avoid a situation that someone will try to generate with our chatbot a hate speech because we will be attributed to that, and so on and so on. And then we are iterating over that business context that is important from their end, and also it will be an input for the whole risk analysis that we have. And then we will use all of that information to generate threats. And actually, to generate those threats, we can either rely on our experience and use those security personas that are in the room. Usually, there are 3 different people from the security side in such exercises. So as I told you earlier, we have our business people, we have our developers, but on the security side, we have someone we call a security guardian at AWS. Those people are subject matter experts about security. Those people are actually so knowledgeable that they are moderators for the whole discussion, and they are making sure that the whole process is actually going well. And they are also providing inputs for the next phases, and they are evaluating if that discussion makes sense. But the main generation of the threats is coming between 2 different personas on the security side. One persona is adversary, someone who will think how to do bad stuff to the system. And another one is actually a defender, someone who will protect all of those systems and thinks about mitigations. So having those 3 people, we can do all the brainstorming we can do. And again, if we have experienced enough people, we can just leave it there and do not use any external source of truth. But at the same time, if you are starting with threat modeling, or you would like to make sure that you didn't omitted anything, maybe we can leverage some industry level thing that will help us to generate all of those threats. And thankfully, we have threat frameworks prepared by the security people and our industry to work with that concept. So one of the threat frameworks is Stride. Have you heard about Stride? Raise your hand. Not so much. So Stride, 6 letters, acronym. It stands for 6 different categories of threats: spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege. 6 different categories, and this is already giving us 6 different kind of threats that can happen in our systems. So for spoofing, we may have a situation that someone impersonates other user. For tampering, someone actually tries to work around signature and all the security that we have in place. Information disclosure, denial of service, all of them should be familiar from you as the concepts. And Stride is actually one of those frameworks. So you have other like Dread, Meter Attack, you can have Octave and many, many other frameworks that are available there. The bottom line here is that you are using them as checklists, guardrails that will help you go throughout the process and generate as many threats from different categories as possible. And you are doing this to have the consistent output and consistent approach, because otherwise you may omit some important areas and details. And when you are doing this kind of exercise that looks more like art than science, all helping hands are valuable. So definitely having a threat framework as an input is also important. But that's the third input for this generation phase. There's another one which may help us. So we are not working in isolation in our industry. There are other systems, there are other businesses that already did this exercise. They were already exposed to certain threats, and they are happy to share that as industry-wide information. So we can actually base all of that, use that information to base our process. And again, you can use stuff that is paid and available under the paywall, commercial alternatives. But I think many of you, especially if you are developers or architects or security people, you heard about OWASP. How many of you heard about OWASPs? Thankfully, majority of the room, if not everybody. So OWASP is the organization, non-profit organization that actually documents all of that stuff that happens with the security and that includes existing threat sources. And you probably heard about OWASP Top 10 for web applications and all of the top popular security problems with the web applications. But they are not stopping there. They are providing a lot more information. That includes also large language models and generative AI space. So as you can see, in addition to threat frameworks, we already have 10 different categories of things that can happen with generative AI workloads. One is the prompt injection. Another one is poisoning of the training data. We have over-reliance. We have model theft. A lot of good insight for the whole process. So again, having those 4 inputs to our process, now we can generate threats. We can actually think what can happen wrong with our systems. And then having those threats, we can think how to exploit that, how the attack steps will look like. So we can document those threat steps in a way that we will do the free-form analysis, and we will leave that as a free text. We can just write prose and all the information that will be around the threats and how to expose it. But then again, we will have this problem like human language is too flexible to quantify, because we will not have all the common steps if we will use free-form text, and that will be very hard for us to compare different threats between each other. What is the risk, how to compare the risk, and so on. So those threat statements can be written in a way that we are having a shared grammar for them. And there is a very specific way to handle that, and we will see in a moment. Before we will go to the threat grammar, let's evaluate the scenario that is positive one and the scenario that we will write down as a threat. So our customer wants to get access to the customer data based on the provided input in the chat, and that will include semantic search and generation of those embeddings and asking the model to generate the similar buys that we would like to do. In order to do this, we need to generate queries for customer data, those embeddings, throughout the LLM model. So that's the happy path. And we do this through providing prompts about our data. So we are typing what we would like to buy, and maybe we are providing an image as a part of the whole semantic search experience. So this is a good flow. However, if we will switch and we will use an authorized user as our adversary, we need to, in order to get customers' data that we are not authorized to get, we need to do something malicious with the prompt. So usually we are trying to fool the LLM to think that we are allowed to do this, but we are really not. And we are doing this through the jailbreaking by providing some special keywords, maybe some additional system context information, or sometimes by just repeating the same stuff. Depends on the model. But the whole scenario is actually a threat because we, as unauthorized users, we are exposing this malicious prompt to get the data that we are not allowed to, and we would like to write it down in the correct way to make sure that it will be comparable to the other threats that we will generate. And now we are using the threat grammar. So as you can see, we have this statement that has those square brackets. And those square brackets are actually optional, but recommended things that we need to think about when we are writing down a threat. So we are writing down a threat source, which means who or what entity with which prerequisites can do a certain threat action in order to achieve the impact and then either negatively impact the goal or negatively impact our assets or both. And as I said, all of them are optional, but it's always good to actually include as many details as possible if you can. So in this particular scenario, first line will be replaced an external threat actor with access to the public-facing application can inject malicious prompt which override existing system prompt, resulting in data for other customers being returned, which impacting confidentiality of the data in the database. So this is our filled threat statement that can be compared to the others because it shares the same grammar. And that particular thread statement is landing in our table finally. So we are returning to the table that you've seen at the beginning. Obviously, we need to provide this identifier, but this is however format we would like to have. It's just for the referencing perspective. So we put the thread statement that we created here. We also added priority. That's based on the business insider information. So for them, I mean them by business, they are actually very worried that it may negatively impact the confidentiality. So that's for them is a high priority. And last but not least, we put S and I in the stride column, which means that we are both doing two different category threads here. Spoofing, because we are impersonating a user that supposedly has access, but it doesn't. And then we do the information disclosure, which is I, because we are exposing that information to the malicious actor. So far, so good, but we still have one column missing left. So let's investigate the third step. But before we will do this, we need to think how the attack will look like. Because the malicious prompt is one of the things that you can actually very unprecisely define as a thing. Malicious prompt can be everything, really. So what would be the attack steps for our threat? First, application accepts any prompt from the user. That's a fact. At the moment, there is no additional sanitization. Then this prompt is passed to the LLM from logic. LLM uses this prompt to generate the query, and the query result is passed to the user via LLM response. So those 4 steps are actually all of the attack steps that needs to be filled in order to exploit that particular threat. So now is the time to actually answer the third question, how we can mitigate the whole threat and what we are going about it. So again, this will be a question to our business. If that's a very high priority threat, we will need to mitigate that. So it means that we need to reduce the risk as much as possible that this will happen. So in this case, we will develop mitigation, but we will not do just a single mitigation on the first step, because you can always do the first step mitigation for defining acceptable use within the system prompt. That will be the easiest way to secure your application from the LLM perspective. But many of you know that this is very easy to work around. Like, if I will define something acceptable, all the adversary in the world will definitely, with their creative minds, create something that will work around all of those guardrails. So one layer of security is not enough. Let's actually use the good practice of having security in depth. Let's apply the mitigation for every single step. So if we define the use within the system prompt here, we can go with another mitigation on another level. We can sanitize all of those known parameters. If that's not enough and the risk is still too high, we can go beyond and we can go and predefine check acceptable statements that will be passed to the LLM. And then as a final result, we can validate the output and make sure that we are having access and access control is in place and return data is actually allowed to be seen by this particular user. So what you can see here is that on every single step, we are defining another layer of security here. And the solution and mitigation here is not limited just to the LLM or generative AI. For example, here we are providing additional guidance for the LLM from the perspective of the system prompt. That's something that we will do through the model and through the generative AI. But validation, if user has access to something, I think that sounds similar even without generative AI. It's called access control authorization. So we can actually do other mitigations for the generative AI vector attack space that will not touch anything on the generative AI, and that will be still fine. So again, it looks like that generative AI is just a piece of a bigger picture. It's not the whole sense or something that it's beyond everything. So having all of those 4 mitigations, we can actually move them to our table in the mitigation column. And again, we are using some kind of identifier to connect all of that. So far so good, but we just finished a first row. Where are the rest of the rows? Like, that's not only thread that we can have. So actually the whole exercise seems very complicated and tedious. But at the same time, there are tools that may help you, and in a moment I will show you. And one additional thing is that we started with the first visible row, and we started obviously with the prompt injection. But what about the others? And there is a good way of applying a certain, in a reproducible way, a certain set of exercises, which is called stride per element. So we are decomposing our application in a way that it will be evaluated per element when we are doing stride thread framework, and we are using stride framework for that. And one thing additional is that some of you may ask, okay, so you need to have a huge experience about those mitigations to actually develop them and brainstorm. Maybe and maybe not. We can again drop into the recommendations. In OWASP Top 10, it doesn't matter if LLM or web applications, there are some information how to prevent certain threats. For example, here in prompt injection, you see that privilege control, human approval, segregation, and so on, all of those things are preventing what is happening with this particular threat. So you can use it, and you can actually implement it and provide those mitigations based on what is written in OWASP. So let's move to the very quick demo that I would like to show you. How to make the whole process repeatable and a little bit less tedious in that sense. So there's a publicly available tool that you can either use from your browser or deploy in your security perimeter in your organization, which is called Threat Composer. And this is an open source tool. At the end, you will have a QR code to all the links, so don't worry. But you can actually deploy the Threat Composer in your own security perimeter or use this example to have a tool that will help you guide you through the whole threat modeling process. So how it works? Essentially, you are creating those examples and workspaces, and I have, luckily, the example for generative AI chatbot. So this is the end result. We are starting from a dashboard that will show you all the threats that we generated for that particular exercise. You can see the threat prioritization, distribution per category, and you see that there is a stride here hidden because we have spoofing, tampering, and so on. You can also see a threat per grammar distribution and how many of that is can be filtered by the threat priority as well. So this is a summary of the whole exercise that we did. But how the whole exercise was done. So first things first, we need to go with the question number one. We need to provide all the information for what we are building. So in the first step, we are providing application information. And we are putting here all the details. Motivation, what kind of source are used, what is the criteria for providing threats, what is the agreement. We are providing information about the technology choices, and we are actually including some additional links to the documentation. So this is one of the things that you can copy from your wiki, existing documentation, and that will be a very good starting point, but that's not enough. We need to provide a little bit more, and we will obviously need to provide the architecture diagram. So we need to provide the diagram itself, but also we need to provide the legend for the diagram. So we need to explain what is the solution architecture and so on. I told you that the architecture diagram is having too many details in some cases, and it's not comprehensive enough from the security perspective. So we will also provide the data flow diagram. And with the data flow diagram, we already have identified something that we called zones of trust or trust boundaries. So as you can see, those dashed line, the red dashed line, is actually separating certain groups of elements of our applications that are treated in this exactly the same way from the security perspective. So our front end and API is treated as one trust boundary. Another one will be authentication layer from, in this case, Amazon Cognito. And then we have our trust boundary for the business logic. We also have different trust boundaries for external services or for the LLM. And we are doing this to actually make sure that we are classifying all of that is happening in common way when it comes to the whole threat modeling exercise. Obviously, in that step, we also provide information about what's the legend for that diagram. So we need to document all the data flows, again, trust boundaries, entities, and so on. And that was a lot of writing, but this is still answer for the question number 1, right? What about the other questions? Being still in the question number 1, last but not least, we need to document all the assumptions. So here's the place when we are actually documenting those assumptions, and we are adding this and make sure that, for example, if we assume that the LLM training doesn't contain any sensitive personal information, and we assume that from the beginning, we need to put this as an assumption because we will later need it for threat modeling. As you already see, because we are doing this after the fact, all of those assumptions are already having linked threats and linked mitigations. And this is actually answer for the question number 2 and question number 3. And this tool is helping us go through the whole experience by just providing you a wizard. And as I told you, if we are generating threats, we should stick to the grammar. So we have this particular grammar available, and then we can either fill this out based on our experience and what we brainstormed, or you can actually go with the random example and then modify it based on your experiences. So that was already provided, and maybe makes sense from our perspective to keep it. We need to evaluate it, but at least we will have a shared understanding. If we will go to the threat list, you will see that the created threats have already linked assumptions. So we will go a little bit below and we'll find some the thread that has linked assumption. You see that a particular thread number 25 has particular tags available. So this is OWASP LLM09, which is over reliance. And we already linked an assumption to this that end users are trained properly on interacting with the LLM system. And that was our assumption regarding that particular threat. But again, assumptions, threats, what about the mitigations? So in the last step, we are actually documenting all of the mitigation. And again, we will use the way to define this with the help of a wizard. So you can actually write down the mitigation, then you can link the threat and assumption and provide additional metadata. So for example, if we have mitigation number 1, which means we would like to segregate user prompts from system prompts, you can already see that this has an information how we can implement it with the instructions and guardrails and so on. And as a result, you will have this whole threat model document that will generate the table with the reference and the identifiers for you. And that will be much easier to keep up with the changing system, because the whole threat modeling exercise is not a one-time exercise that we do within the teams, but we are doing this continuously when we are evolving with our software. A good recommendation is to include it in your software development process. So if you are using agile methodologies, for every single sprint or feature you are delivering, that would be a good exercise to do. It may sound and look like a lot, but at the same time, if you are having a smaller scope, like a feature, this exercise is not as time consuming as doing this for the whole application. So it's already much easier exercise to do. So if you would like to use this tool, again, Threat Composer is available on GitHub as a public and open source project. And let's go back to the presentation to finish. So We have our demo, but someone may ask, okay, Wojtek, haven't you forgot about fourth question? What about this one? And yeah, this is a very important question. Like I said at the beginning, this is not something that we are doing to make sure that we did a great job with security and we do self-patting. We are actually trying to verify if the mitigations that we implemented are correct, and we also validate if the process that we used is correct. So we can do this on two different layers. In order to verify mitigations, we need to do what? Probably pen testing and checking if that particular mitigation is secured, is actually in place to that will protect us from the consequences of the thing that is happening. So you can do this per release, in a recurring way, on a surprise, depending on your offensive security team that is actually implementing that pen testing. But that's one way to verify mitigations. You can also use automated testing. SAST and DAST, those are acronyms like static application security testing and dynamic application security testing. Again, you can use this in an automated way, ideally within your CI/CD pipelines as a part of the bigger process. But again, this will verify if the mitigations that are in place are actually securing the risks in a proper way. But then there is the validation for the whole process. So you need to compare if you generated enough threads, and I encourage you to not just look on the single thread model. Stride may be good enough for you at the beginning, but if you would like to expand, maybe other thread frameworks are having more coverage that will be interesting for you. And maybe you can leverage other teams that are already did this exercise and those kind of thread modeling exercise in your organization. Maybe they have some advice or they have some knowledge that will be important. And also, if you have those people either inside your organization or close by available, ask them for feedback, what they think about the whole process. Did we cover enough ground to actually generate all of those threads? Is that complete? Is that clear for you that the whole output that we created is something that we would like to improve later on? What can we improve, and so on? So to sum up and wrap up, if you would like to have access to all the tools and details, you can scan this QR code and you should have access to the thread model, thread composer, information about Stride, and also the repository with the example application that I shown you as the thread model thing. So I will leave you here for a brief moment to actually scan the QR code. And yeah, if you would like to dive deeper into that topic, or you will have further questions, you have my contact details on the slide. And last but not least, this is a feedback survey about this session. So if you'd like to give me an honest feedback, this is an anonymous survey, so feel free to leave your honest feedback there. I would be very, very grateful. That's everything for today. Thank you so much, and thank you guys for inviting me.
Thanks, Wojciech. And I will ask you guys to leave the feedback. It's really crucial for the speakers to receive the feedback from the audience. So please go ahead and left. And we have actually 5 minutes for the questions. If some of you want to ask something, or you also ask them as well during the networking, we're also ready for that. So if someone would like to raise it for the bigger audience, feel free to raise your hand. Oh.
Yeah, sure. Let's go.
Let me bring you a microphone.
Okay, so to me, in the process of threat modeling, it seems that the most complicated part is to generate threat statements, and most creative, of course. Mm-hmm. Have you tried to use LLM basically to generate those threat statements based on project description, for example?
Yeah, so that's actually a very good question, and so there is a way to do it. The question is how much trustworthiness you have, and faith actually you have in those generated things. And I have actually a very short demo that I can show in a moment. of something that is Amazon Q Developer, which is actually trying to help you with the whole process and allows you to generate that. So if we still on stream, that should be available for everybody. But essentially, let's imagine a situation that you are landing in the repository that you don't know. It should be much more legible right now. So you are landing in the repository that you don't know, and you are trying to elaborate on top of that. So you are actually evaluating what this project is doing and so on. In Amazon Q is something that you are installing in your IDE as a side chat. So you can see that I opened a chat session with this particular tool. Obviously, you need to authenticate. You can either use Builder ID or use something that is provided by your organization through the Identity Center. But essentially, it uses the context of the IDE and its own knowledge to work with it. So to save the time, I have already some prompts prepared. So you can ask regular questions to the chat. Okay, so it broke because of I need to restart the IDE. Sorry for that. So let's go once again. It should be better. But essentially, we will do the interactive session and exploratory session with the AI companion throughout my code. So I can ask it regular questions like, what is the threat modeling? And it should answer with the information, what is this? Without leaving IDE. So it provides me information, okay, so if you would like to do the threat modeling, this is a systematic process and so on and so on. Good answer. But that's not helpful in your context, right? Because you asked, can you generate something for me about this particular application? So let's ask it to generate 3 sample threats for the current project. That is much more helpful question. If I will do it right away, it will say, okay, so you have README MD opened, which already has some information for me. And I detected that based on the information provided in the resources, sorry, it didn't do this for the README because it wasn't active. So it said provided in the web resources. So that's one of the things I need to be careful about because currently it takes only the open file context. So let's ask it again. What are the 3 sample threads are for the current project from the Stride model? And then based on that README, it should detect that, yeah. Okay, let me rephrase that once again because I screwed this up because I unfortunately did the wrong job with asking it in the first place without open README MD. That's happening with those tools. Yeah, in this particular case, it detected that based on Stride, spoofing, tampering, and information disclosure can be something that is actually problematic for this particular application. So I can also ask it for the provided context, please generate me one thread per Stride element. So it already should know that Strides consist 6 different ones. And again, it failed. Sorry for that. Once again, I will close all of that and ask it to generate it based on the README MD. Yep, you need to be patient. So let me open this once again. Let's ask it properly in the context of this session what this application is doing. Yeah, now it detected that based on the README files, it says that this is the generative AI stylized newsletter when you can define newsletter frequency and so on and so on. And now, hopefully, when I will ask, first, let's ask it for 3 sample threads. Maybe this time it will be preciser. Yes, thank you so much. So finally, we have the information disclosure based on the README file and based on the project context. So Application is generating and handling potentially sensitive data and content for newsletters. There could be a risk of unauthorized access and exposure of information. Good enough. Let's say this is a very generic one, but it's good enough. Potential mitigation strategies could include implementing robust access control, secure data storage. Yeah, good enough. Tampering with data. Since users can customize generative AI prompts, there is a risk of malicious actor that it's actually attempting to tamper with the prompts of the generated content. That's also a good threat. We can actually start from here. And then there's the denial of service. So it looks like that application is likely handling significant amount of newsletter generation and distribution, and this could be something that will be vulnerable to DOS attack. Yeah, good enough. So if I will go and follow up with the prompts, and I can actually use another prompt, this time ask it to generate it per element. So we should have one thread per stride element now. So hopefully, based on the context and what it generated, it apologized me to not generate it.
Because you forgot about the tips. You should always promise the tips for the AI model.
Yeah, exactly. Probably it doesn't like me. This is one of the things that you should be evaluating when handling those tools. It doesn't like sometimes security context, security specific topics. And I actually, that's why I prepared those prompts to actually make sure that I'm having a repeatable experience. And as you can see, I don't. So let's try to evaluate it and change. For the provided context, generate one thread per stride element. So one specific thread from the thread framework stride. Let's try this way. Yeah, no luck. Yeah, I will leave it here. Exactly. Maybe we can actually go through the networking session and try.
To the next question.
Yes.
Okay. What is the use cases for this thread composer? Is it only for chatbot? What about like text to image, image to image? And
No. So the thread composer tool is actually to guide you through any threat modeling exercise. So if you have a regular application that is not even touching generative AI, it's still helpful because it actually allows you to go step by step in a repeatable way. It's like a tool that keeps you on the track, essentially. So like you are going through a repeatable experience, like you are filling Jira tickets or something like this. So essentially, this is a helpful tool that generates the documentation at the end, no matter the type of application you are dealing with. This is more or less a tool to automate the tedious experience, because the threat modeling is fun as a brainstorming activity, but documenting the results of threat modeling is actually very tedious. So this is one of the tools that can help with this. And hopefully LLMs, when they will be better, they will also help with this as well. I hope this answers.
Hi,
Yeah.
thanks for the presentation. Regarding the testing, how to validate your threads. Not every project have access to a red team expert to handle that. So
True that, yes.
Beyond the automated tools, any other insights that you may have to help people to validate this?
That's a very good question, and very right point. Like, not every organization will have a red team or the offensive security team. So from my experience, you may handle this in a way that you will handle the regular testing, the functional testing in your teams. Sometimes you have QAs, sometimes you don't. And what we did in our teams before I joined AWS was to cross-test our stuff. So you as a developer, as an architect, you have that knowledge about security testing. So sometimes you can actually do very basic stuff. But I think the caveat here is that you are not an expert. And another thing is that don't test your own stuff because we are biased at the beginning. But if you will do this in a cross-reference way, with proper maturity of the team, I think it can be a nice replacement. Not something that will be very comprehensive, but at least a replacement. And there is a last question here in the first row. Thank you, Anton.
Okay, you were mentioned that this modeling can be applied into a agile framework of projects. We have to define these threads into the beginning to be working on the iteration. What if we found a new thread while we are implementing a new functionality? We can include it into the list to be working on?
That's a very good question. So I would say yes, but I wouldn't return to the threat modeling at that level, at that point. If you are detected something at the implementation level, yeah, it depends on how high priority it will be. Because I can imagine you can detect something minor, but you can detect something big. And I think it depends on your definition of done. If you will deliver a feature that will not be secure enough, and your definition of done is actually considering this as a must, so I think this will be a no-go to release. So it depends on the definition of done, but in many cases when you are having minor stuff, it's good to actually document them for future iterations. The one thing that is important is that you don't have to start with the full model from the get-go. Like, if you are starting this whole exercise and you are just developing new feature or new subsystem, I think it's perfectly fine to just focus on that and then iteratively build over and make this model more complete. Like, I understand that there is a temptation to have a full model since the beginning of the implementation implemented and ready to be used. But at the same time, it's not as pragmatic as it may look like, because this is a heavy exercise. It will require a lot of work. And remember, all models are wrong and some models are useful. Like, you will not be able to prepare ideal model anyway, because it will be a simplification of the reality. But at the same time, if you will have a comprehensive enough model built over time, it will be useful to have it and use it in this particular context. So my answer will be, I would refer to definition of done. I will check if that's critical for the release of that particular feature. If that will be severe enough, I will withdraw this task and then try to reiterate. If not, add to the backlog. Obviously, not for the end of the time. Sooner than later, I hope.
Guys, okay, last question, very quick. We almost out.
I'm standing between you and pizza, so I think this is...
Yeah, thank you for this presentation. How do you define efficiency of threat model? There can be, as you mentioned, 100 points and not relevant points at all.
Oh, yeah.
So probably there can be some kind of monitoring for it, dashboards, and at some point of time you just say, hey, we have pretty good model and we can improve it.
That's a very good question. I think this is like evaluating how good the model is and how much return of investment you have. It boils down to the question how much risk we mitigated through the implementation of those mitigations. Because if we will do the exercise for the sake of having a documentation, and all of those mitigations are detected and listed out, but we do not implement them because we don't have time, we don't have anything else, and nothing bad happened. Yeah, it's like, first things first, it's tempting the faith, like maybe something bad will happen and we didn't implement this. But another thing is more important in my opinion, like if we haven't implemented that in the first place, so what was the motivation to actually include that mitigation and that particular threat? Because as you said, it may end up in a situation that you will have hundreds of threats and maybe 30 will be important. So my question, my ask will be, approach this pragmatically and validate with the business the risk. Obviously, it's not helpful if business is saying this is high priority for everything. That's why we need to challenge them and make sure that they are understanding that we have certain amount of capacity to implement stuff, and you need to select top 10, not top 100. So I would go with like ruthless prioritization and try to be very explicit about capacity, about how to do it. And then the next question is how to assess the return of investment. And that's a tough question because it's like with insurance. Like if you have insurance for your car, I'm not I'm not saying that the regular insurance that you are obliged to do, but the AC insurance for the car. So something that is protecting you from random damages. Is that worth enough? Probably if nothing bad happened, you will think that it's not. And having that particular model and all of those mitigations implemented in the first place from that model is kind of an insurance strategy. So I think that everything boils down to the risk analysis. If business is telling us that this is a high priority risk and we need to fix it because there will be irreparable damage to the company because of that, that's important. If that's something that they are thinking that this is important, but we are challenging them and we see less and less persistence, maybe this is not as important and we should be pragmatic. So I would try to be as pragmatic as possible at the same time adhering to the risk analysis, if that makes sense.
Thank you, Wojciech, for the beautiful presentation. And I would like to say goodbye for our global audience and thanks for coming. And we are probably will go into the networking. So hope to see you next time. But we have, as you know, some AWS credits, Wojciech, and you actually had the 5 beautiful questions.